Okay, so I think we can get started now at this point. So hi everyone. I hope you're all safe and well these days during the quarantine. Welcome to Glovo's first ever virtual meetup. We're super excited to have this. In this one, we're going to go over mobile development at scale, as the title says. I'm Anna Bertoldini. I'm Glovo's employer branding specialist. And with me today, I have as our amazing speakers, Roldan Galan, Guillermo Mazzola, and which are Glovo's Android engineers, as well as Mauro Vime, one of our iOS engineers. They will walk you through our webinar today. So without further ado, I'll pass it to Roldan and Mauro for the first part of the presentation. Thank you everyone for joining.
Thank you very much, Anna. So let's start first for the mobile continuous. Oh, sorry, let me update my video. Let's start first for the mobile continuous deployment, and we want to tell you how the Glovo mobile apps are deployed here at Glovo. We're going to split this talk in two parts. First, I will start explaining you a bit of the context and how we evolved to have this continuous deployment setup, and then Mauro will go into more details. As you see, we are iOS and Android developers, and we are the ones that we've been in charge of doing the release on Glovo for the mobile apps since more or less since we joined. And that's why we eventually thought that we really need to do continuous deployment and continuous delivery, as doing it manually, it was not having the best quality that we wanted for our applications. For starting, first, a moment of silence. If you are mobile developers, probably you have been using Fabric facilities for a long time. And 2 days ago, they just shut down forever the service. And I think it made us super sad, all of us. They say all the team is now in Firebase. So this should be the same, but for me it's not. The US a bit slower, but I hope we are going to have the same exactly things there as well. And let's go first. So a few hours ago, I realized that we were doing a continuous integration and continuous deployment talk, but we didn't have any slide about what is the definition of all of this. I think everyone agrees on the continuous integration part, which is verifying automatically that the integration of multiple contributors in the project is fine. I mean, in some definitions, you don't have the verification part, but I think it is the key. I mean, if you are integrating part of a lot of developers in the same project and you don't verify anything, for me, that is not continuous integration. Then the CD part of CI/CD, sometimes it means continuous delivery, sometimes it means deployment. Continuous delivery is a way of producing software in short cycles, and you are sure that everything is deliverable in any moment, but you still don't have any automation for the deployment. And finally, we have the continuous deployment, which is what we all would like to have. And first, you need continuous delivery, and then you need to automate your deployment. And then if you are able to do this, you can have continuous deployment. Some strict definitions of continuous deployment say that every commit immediately, automatically go to state and to production. As we will see, for mobile, this is not possible or even desirable to send every commit directly into production instantly. But we are going to tell you how close we can reach, or how close we reach at Glovo. First, some numbers. In the software industry, I think everyone agrees that continuous improvements are a must. Everyone agrees that automation has better reliability than any manual task. And this is more true as a company scale. So if you see in these graphs, the left one is people using CI/CD, the right one is people not using it. And the colors represent the number of employees in the company. So as you see, as the companies get bigger, they have more and more adoption of CI/CD tools. This makes sense because CI/CD system requires some resources and some team capacity that maybe small companies cannot afford. And also all the advantages that you get for CI/CD are more noticeable when you have a bigger team, because you have more problems that you will solve. So, however, even if everyone agrees in the industry that this is how we should have, in mobile, we shouldn't be really proud of ourselves. We are, in every study you read about CI/CD, we are always in the bottom. There is always more adoption on CI/CD on desktop, on web, on backend, of course. but mobile is like we are the last ones reaching here. Why? It might make sense to be behind all of them because we have several constraints that if you compare with backend or web, it makes really harder for us. So just starting as Android developer, I'm going to make fun of Apple. Just starting with this, you have at least 24 hours of review. If your app is small and is the beginning of your times, the review time might be even bigger. So how can you publish into production 10 releases per day if Apple is going to review it in 24 or 44 hours? But even if in Android we don't have, it's not possible in Android neither. First, automatic updates are not mandatory. I know that this was true in the long time ago that most people was not updating their application, but every day more people have this update, but still it's not something under our control. We can control if they have automatic updates or not, so it's impossible to know if they are going to be up to date. Even so, if we try to publish 20 updates a day, the user will see some pop-ups of the updates and will be some concern about that. Especially if your company, I mean, if we are in Europe, maybe we usually don't care about bandwidth. But if you're working for a company like Glovo that is operating in several countries in the world, sometimes you need to care about the bandwidth. You need to remember that not in every country the Wi-Fi penetration is the same. The rate of the connections are more expensive, and you can consume the data of internet if you do a lot of updates a day. Also, the updates are not instant. So in the moment you publish, it takes a while until it replicates in all the servers, and it takes some days until all the applications are updates, even if they have automatic updates. And last but not least, it's something that a lot of people don't remember in mobile when talking about this, is that we are releasing a single binary. In backend, especially if they have microservices, if one piece is broken, you just roll back this small piece, or you publish a new release of this small piece, and you don't need to halt the whole release at once. In mobile, even if just one small piece is broken, even if you have your whole application modularized, if you have whatever libraries, at the end, you are releasing a single binary, and if something is broken, you need to stop the release, and you need to publish a new hotfix for this one, for the whole thing. And it's impossible to do a full roll. So with all of these countries, it's really impossible to do a full rollback in mobile, which is quite dangerous if you publish something with mistake. So let's see how close we reach to a continuous delivery and deployment process here at Glovo. First, let's start for our work process. We are following Git flow, and I want to tell it with care. I'm aware that being recently with the guy who invented this last month, published a message in the post saying that this is quite outdated and we should move to something else. But I honestly think this really fits for mobile. So because in mobile, as we said, you have different versions always published. So just a brief reminder, Git flow says that you have a master branch, which represents everything that has been already released, and a develop branch, which represent anything that is releasable. So going back to the continuous delivery definition, so everything in your develop branch will be ready to be released. We do pull requests, we do pull requests, small pull requests, we do code reviews, we merge frequently, we use feature toggle, and all of this latest part is the with care part of Git flow that usually some people think about trunk-based development, about these techniques, but you can apply all of these techniques also in Git flow and having a more careful workflow. We have a continuous integration setup. Everything in every pull request, all the code before being merged is integrated with develop. All the tests must pass. The coverage cannot be decreased. Every new code must be at least 50% test. We have static analysis tools in place, and now we are working on UA testing. I'm talking about this part of continuous integration. The talk is not going to be about this. We're going to focus in more in all the continuous deployment part. But I wanted to just to highlight that you cannot have continuous deployment if you don't have a good continuous integration setup. And now and remember that for having test integration, you must have test. So, and test takes time. It's easy to do the minimum, so we really recommend you to do some enforcing in the pull requests as the one that I was mentioning before. A year ago, our numbers were really shameful, I must say. But as the team has been growing and we had really full commitment of the whole team on testing, we've been increasing a lot. And we've been passing from roughly 10% to almost 45% in 1 year. I know, especially in small companies, this usually is hard because maybe at management level, people think that since test takes time, you'll have times for features. So it's always helpful to have management on board. And I can say that we have upper management fully supporting our test coverage process. And after this brief introduction, let's tell you how everything changed. At the beginning, like Glovo started like 5 years ago, but I'm going to talk just 2 years ago. At the beginning, the structure was quite bigger as we is now. We have just a few developers per platform. I think the engineering team, like 2 years ago, 2 years and a half, was there 30 engineers. And in the customer application, I think in iOS there was 1 engineer. It's Mauro, who is going to take on later. And for Android, this was another engineer and me. We just have a few product managers, just a few stakeholders. Even if we wanted to work fast, we thought we were working fast, we didn't have many branches, many pull requests, we didn't have many conflicts. We also didn't have a huge number of customers. And our release process was no release process. Releases happened manually, of course, in 2 scenarios. First, when product needed a feature to be released as soon as possible, which, as you might know as developers, this is the biggest part of the week. So every feature need to be released. And when this was not happening, as soon as we had enough stuff ready to release, we were doing a new release. And we have a pre-release beta program in place just for internal employees. But this was also doing randomly. It was not defined in any way. I'm missing another really important reason to do a release, because I was so ashamed to put it written here. So I'm just going to say it. And the third reason to do a release was a hotfix. I think back then I was recently checking the data, and I think we were doing 1 hotfix per release. So that was a really good reason to do releases. And this is more or less how we feel about this release process. It really looks crazy and random now with the knowledge that we have now, but it worked. It worked because we were a small team. And when you have a small team, really you don't see the necessity of really having a hard investment in CI/CD tools. But then the team started to grow, and we started to care about this more. So we started to have more developers. These developers were in different teams. This team has different product managers. There were different stakeholders related to these teams. We were having more and more branches, more and more pull requests, and more people wanting to release more features. More people wanted to know when the releases were happening and what was included. More people wanted to have their features released sooner. And then we realized that we need something else. We need to set our release process. So I think this was by the end of 2018, we started to do more cyclic releases. And basis of this, we start to set the basis for the release process that we will set at the beginning of 2019 with Mauro. And these were based on 2 core concepts. First is releasing in regular periods with fixed dates instead of whenever someone wants something. And the second one is doing canary releases, which basically means slowly rolling out the features to our customers. Don't doing the release to 1 million users at the same time, just doing slowly and observing and monitoring the release to see if everything worked fine. In a bit more detail, our release process, we choose Monday to do the public release, so we could do a state rollout until Thursday. We choose to do a beta consistently 5 days before production, which is Wednesdays. And that day we were releasing doing a release branch. We were cutting this release branch from develop. This was cut from features. The developers could be still working on the develop branch, but in this one there was no more feature. Mauro will go more in deep about all of these processes later in his part. This is just an overview of this concept in the release process. We also start to enforce better engineering practices. So for example, we were enforcing at this point, we started enforcing 2 positive reviews before merging. We started to care more about our CI and that it was always working and setting the no decreasing coverage code before being merged that I was mentioning before we started at this point. And we also start to do Git flow and consistently and semantic versioning, because the name of the releases were also a bit random. So we started doing the classical major, minor, hotfix semantic versioning. And just as a side note, we were aligned with the translation team on all of this process to try to be coordinated with them to have the last releases. I forgot to mention, and then we start to look something like this. We increase a bit our reliability, but still nothing to be proud because our code coverage was still a bit low. And even if we didn't decrease a lot our hotfix, of course, we didn't go for 1 hotfix per release. It was a bit lower, but we started to be all more aligned, and we had the feeling that all the team was on the same page. I just forgot to mention that we have a Q&A system in place here in the conference. So if you have questions, you can start typing now, and we will resolve them all at the end. You also can vote questions of other attendees. At the end, once we finish the presentation, we will go over the questions in order, and we'll try to answer your doubts. So after this, the team continues to grow. So in that moment, we were in the part about the continuous delivery that I mentioned at the beginning. So we were still doing all the releases manually. And as the team was growing, this was consuming much of our time. So we were still ourselves doing everything manually. So on Wednesday, we were doing the release manually. On Fridays, uploading to the store. On Monday, the release, and all the days in the week, increasing the rollout. And it was super time consuming. Also waiting features to be finished. So maybe on Wednesday, people saying, hey, I have a feature to be finished in 5 minutes, please wait to cut the release branch. And of course we are human. So we are saying, yes, of course I'm going to wait for you. I'm waiting for me, so I will wait for you, of course. Which is something that will never happen to a machine. The machine, at the time you say, it will cut the release branch, which is quite helpful for that. So we decided we need automation, and that was we couldn't delay it more. Back then, our platform team was quite small. It's composed by really awesome engineers. They are amazing people, but they cannot do all the things for everyone. And then we decided to outsource this to external providers. This mobile agency called Novoda, and they sent to us really cool engineers that they were providing us the solutions that we needed for this. They made for us a custom internal library for this. We call it the Glovo Jenkins Pipelines library. It basically provides a custom DSL that improves Jenkins and made Jenkins more customizable for us. The great part of this is that all configuration we have configuration as code, and it's managed by the developers of the platform of the project. So with this solution, we don't need to depend on the platform team, and we have all the configuration ourselves, the owners of the application of the repository. We have this with the same code of our app, which made us give us a lot of freedom in this aspect. So with this, we managed to have automation for the branch done on Wednesday, automation for merging it back into master, into develop, for doing the Git tagging with all the nodes that we need there, and also pushing the mapping file from prover, and also pushing the APK, which are things that when we were done manually, most of the time we were forgetting. It was also doing real continuous deployment for the beta release that we mentioned before, the beta that we have for the internal employees. So every commit into our release branch is producing a new deployment of the beta app to all internal employees. Of course, on Monday, we were doing the push to App Store or Play Store. Actually, on Play Store is on Friday, the review, but the publish of it on Monday. The rollout update, which in Android is manually, and then also release note management to have announcement. So as we say, we are growing a lot as a company. We are having a lot of teams. Everything have different channels to announce the new things that are in every release. So all of this automation was helping us to deliver everything to all the others. Again, for all of this is a high overview. Mauro will go in more details about what this library was giving to us. And after all of this is how we think we feel now. With all of this change in automation, all of the increase in the code coverage, all the enforcement in engineering practices, doing more code reviews, doing a smaller pull requests, adding more static analysis tools, adopting a lot feature toggles for every new feature we do and even for refactors, a consistent per-release program. Now we are publishing a more stable and robust application. As I was saying, 2 years ago, we're doing a hotfix for every release. I checked the data this year, and we are doing a hotfix every 4 releases, which is not ideal yet, but I think it's quite better number than we had before. And just notice that we are doing releases every time we find in the moment that we do the release, since we are doing rollouts, stage rollouts, we do in a moment that is not impacting to many of our users. I think we probably, our hotfix are between Monday and Tuesday when only, 2% of our customers maybe got the buggy release. So even if we still have one hotfix every 4 releases, the hotfix are really not having great impact for our customers. And now we jump to Mauro. You continue from here. Thank you. We can't hear you, Mauro.
Sorry, I was looking for the control. Now, yeah? Cool. So thanks for the introduction, Roldan, and for the first part. So from my side, I'll start by going through the feature life cycle of a new feature in Glovo and going a bit more in detail of what Roldan presented. So more or less going a bit more in depth of what he explained around our features and our apps. So basically, as he mentioned, all our feature PRs target our develop branch. So they shouldn't target release or hotfix branches, and I'll explain a bit more on that later. And we require all the checks that he explained before to pass. The app or the code base, it has, as he said, like more like 3 stages or 3 states. So we have what we call like in testing state, which would be develop, and it's the code that is ready to release. Actually, the ready for release code that we froze, which is in the release or hotfix branch, and then the code that's actually been released in the latest version in master. For each one of these steps and these stages of the code, as Roldan introduced, we have like three different apps. So we have our alpha application, beta, and store. The alpha application is a testing application pointing to our staging environment, which represents the current stable code from develop. And we use continuous deployment for this. So every commit generates a new build. The same happens for the beta, but the beta runs on the release and hotfix branches and is pointing to our production environment. And this is the app that in fact we send internally to employees in the company to be able to get early feedback. And then there's the store version that everyone gets on Mondays when we release this to the store. So these different builds actually have, as I said, like a bit of different differences. So after the app is released, what's actually the state of these three points? So develop, after a release, develop will always contain any changes that actually happened in the release or hotfix branch. So I'll go in deeper later, but as the release branch has some life, if there's anything new added there, and on Mondays, by following the Git flow approach, we land it back on develop. So develop gains back any changes or hotfixes that we've done there. And the same happens with master. So master on Monday gets all the changes down and includes also a tag on that commit, on that merge commit that points to the release version. And then we defined, as Roldan mentioned, a release train with a 48 hours code freeze for the store builds. And as I mentioned, the first two apps follow a continuous deployment strategy, which is actually we're actually able to do so because we use enterprise means to release these apps as they are for internal usage only. So now I would like to actually give you a short overview of actually how our train looks like. So basically on Wednesdays at 5, we cut the new release branch from develop. And anything that actually merged to the development branch is not included. So it's let's say that we have a feature freeze or code freeze on what is actually included in the app. On Fridays at the same time, so 48 hours later, we consider the release to be finished and we upload the app to review in the App Store, or we upload the binary to the Play Store just to have it there so that we can promote it on Mondays. These times, of course, actually can be modified, as Roldan said, because of fixes. Like before, we were having cases in which people were actually asking for a delay because of maybe needing a new feature. Now we don't do so for that. We might delay this a bit if there's a hotfix or anything critical that needs to come into the release. Then on Monday, if everything went well, if the review went well and the app is approved, Monday at 10 a.m. we will release the app. Also, this 10 a.m. window, as Roldan mentioned, we analyzed it to have the lowest impact in our business. So actually, this is something that as we open new countries in different time zones, we actually review. So maybe at some point we need to change it because there's an impact of some of our markets. So we try to target this in the lowest impact, the moment of lowest impact. And then we also enable it for 1% of our users using the phase release functionality both from the Play Store and App Store. It's also, and now I'll go in deeper later actually what this means because it's not exactly the same for both stores. And then on Thursday, if everything goes fine, we just enable this release for 100% of our users. So, but then some of you may ask, okay, what if one of the hot fixes that Roldan mentioned before comes in, how this train would change? So basically from Monday at 10 to Thursday at 10, we have the chance to release any hotfix that we actually deem reasonable. So if there's any critical fix that we need, a spike in crashes or anything that we really, really need to hotfix and it cannot wait for the next train, because also bear in mind that this train is weekly. So there's not much to wait until the next version of the app is being sent live. We send a hotfix, but also this hotfix is going to enable this release to 100% of our users because we believe that hotfixes are critical. So if this is a small bug, maybe a small UI glitch that is in a certain part that maybe we can even feature toggle off, that's something that we wouldn't send a hotfix for. But then, as Roldan mentioned, there's the bright part. So people might come to you like this red kitten and say, "Hey, can you include this in the release?" So in the process, we define a clear standard and a blueprint of when something should be included. So as I mentioned, we accept PRs and release and hotfix branches if they are critical. And by critical, we mean feature fixes and enhancements. So imagine you've included a feature on the Wednesday cutout that you've been working on, but there's a fix that you want to introduce in the app before it goes live. It's actually more than desired to do so, and actually that 48 hours time window is actually for the company to raise those and you to fix them, and also bug fixes. If there's a bug fix that you detect, if there's a crash that you detect, maybe you need to update a dependency because there's some critical change there that can be included. And then also we can have time-sensitive features. So we all know how companies work. We need to be mindful. So if there's anything that is critical for Glovo, like a new deal, new country being launched, or something that we actually that we cannot miss, of course we can introduce this new feature on the app. But for all of this, we have our police officers, which is actually the build, test, and deploy team. And if you want to include anything, you actually need to go through them. If not, they're going to chase you. Now, probably not, but in the future, they'll chase you through the office of why that has been merged. So that's more or less the overview about the life cycle of a feature once it's ready to be merged from the pull request. So as we mentioned, there's a fair amount of tooling around all of this solution, and I'll go through it now. So basically, before the automation, as Roldan more or less mentioned, we were doing all of this. So not repeat much myself. So on Wednesdays, we were doing the betas that we have manually. On Fridays, the store also manually. Monday releases, all the Git flow, we were doing it manually in our machines. The release announcements, we were like getting all the releases from all the teams and posting them in a certain Slack channel and tagging people. We were doing everything basically manual. And now basically we just moved to this. So now in the entire flow that we explain, we're only resolving conflicts. So if a new release that needs to be merged to develop following Git flow, we get from time to time some conflicts when trying to bring it back. The CI will actually just create a new branch called merge resolve and the version of your app, and it's going to open a PR towards develop, so that all engineers can actually review the changes and why there's this conflict and try to resolve it. So that we need to resolve it in a meaningful way in a short time as possible. So actually we land any changes from the release in develop, because if there were no changes, there will be no conflicts, right? So yeah, so basically all of this turns around Jenkins. So as Roldan mentioned, we have our own Jenkins library, which is a configuration by code plugin that relies on the stage concept. So every branch can actually have different stages, and each stage can have different steps to run. So different stages can actually have different configurations. So we can have configurations on which steps to run, what to do in a successful and a failure resolution of this stage run. We can have cron jobs scheduled for that. And we also can define a relation graph with other steps or stages. So we can say, once this stage is finished, so we can declare a machine state. So we move to that state, and we have these other stages now that actually can be run. So all the steps defined are actually for the corresponding stage, and the custom plugin actually is generic enough to provide different configurations in every repo. So we don't need to worry about changing the library if we need any changes. This allows for really good team ownership. So every team actually owns their own pipeline and needs to own their own changes. It's true that the platform team is helping us on evolving this and helping in these efforts, mainly the build, test, and deploy team, which is part of the platform. But it's also true that teams actually have the power to maintain this and do any changes. So this is more or less an example. I just took this screenshot earlier today from our Jenkins file on the iOS app. I'll go in detail into one of the stages, but this is actually all the stages that we define for our release branches. So we have a stage for building the release branch. We have a stage for uploading to the store. We have a stage for submitting for review. And then we have a stage for the start phase release and force the release to 100%. As you can, now I'll go into it actually about the load to store. So in the to store, for example, as you can see, I cut the screenshot here, but we have 3 stages that actually we're able to run. And by default, the pipeline is going to pick the first one to build on every commit. So every time we push something to that branch and we're here, we're going to build that one. Then we have a cron job already scheduled every 30 minutes to submit for review. So this configuration is the one that the state machine has when we are in upload to App Store. So this is after we upload it. So we ran upload to App Store. The machine now is in upload to App Store as a result of that build. So now we have these options. We have this cron job scheduled every 30 minutes to check on the App Store, hey, has this build finished processing and submit to review? And also we have the option to actually disable the automation. So all these cron jobs, we can actually they usually are disabled by default when there's any error. So we can actually set these to false and not disable them. If, for example, if this case, the submit for review will probably fail if there's anything, the app hasn't been processed already. So we want to prevent this automation to actually halt and not continue. So another part of the tooling that is very important for us is actually feature toggles. So Roldan mentioned the feature toggles usually are thought around chunk-based development, but we think it's really important also to use them with Git flow and mainly in mobile apps. So feature toggles are actually key for mobile releases, and it does control over the production code. So you can actually change how your app is going to behave based on a certain set of parameters, right? So almost all new features on mobile at Glovo include a feature toggle. This is something that, again, is up to every team. And sometimes we don't do it with a mobile-faced feature toggle. We do it with a backend phase, and there's some response that changes based on that toggle. but we do have in some of the parts of the system a toggle that actually controls this new functionality to be able to roll back easily without needing to release a new version of the app and just turn off this new functionality. We have our own internal implementation. We know that there's several platforms that provide those, but we have our own internal one. And actually, I would say that the biggest two features that this might provide for mobile is actually, as I said, the kill switch. So with a simple configuration change, we can kill or turn off a certain part of the application to mitigate maybe a bug. And this can, for example, include app version targeting or country targeting. So there's some, we are able to identify the group that already has this issue, we can turn it off there. Also, there's user targeting, as I said. So this feature actually is used both by product. So product can actually phase roll out new features to different countries or different cities, even within the same country. And we also use this to actually enable sometimes features only internally. So we only enable it, for example, for us or for some employees of the company without enabling it to our entire user base. Because imagine that we enable it and there's like a bug because this wasn't ready actually to be shown to end users. I don't want my cat to actually look like this. So basically, and for all of these in terms of platforms, as a big overview, so we use App Center for all the enterprise releases around beta and alpha, and let Roldan actually at the end add a bit more on top of how this is going to look like in the future, maybe. We use Jenkins, as I said, as an orchestrator for all the pipeline. On iOS, we use Bugsnag for crash reporting. On Android, we use Firebase for the same means. We use Datadog as an observability platform, not only on mobile, but in Glovo in general. And we feed from Bugsnag and Firebase data into Datadog. And also as a tool and as a platform, we use Slack channels to actually communicate all these changes to stakeholders. So actually, one of the biggest parts that is not only about engineering, it is not only about code and how to be safe, is actually communication. So we thought that it was very important to actually give value on this in the presentation for mobile releases, because when you have all of this, you need to actually be structured. So as we've mentioned, we have our own release notes. So before we had a single release notes file that everyone would just update in every PR, right? As you might see and foresee, this was creating huge amount of conflicts as the team was scaling. So we moved into having just a folder with a set of files, and every developer, the only thing it needs to do in a new PR is just add a new file to that folder, but not a new entry to the same file to avoid conflicts. We name these files usually after the Jira ticket or the ticket from Clubhouse or whatever platform we're using to make sure that it's unique. Then our release notes actually should include the following format. So we always start with a tag about what team and what type of feature or what type of ticket we're resolving. If this is a tech ticket, a feature, then we have a short description of what is this solving, and then the ticket number. As I said, also in the name of the file, we have a ticket number here, so that anyone that gets to see this actually knows where to look for. This final list gets refreshed on every change to the release stakeholders. So every time there's a new push to a release branch, we gather the entire list by adding up all the files, and we resend it to all stakeholders so that they are aware of any changes that the release might have, since we blocked it on Wednesdays. Once the app is released, we gather all these notes and we actually group them by teams. So that's why also the tag at the beginning is important. So we group them by teams and we send only segmented parts to the relevant stakeholders of every team. And we do this through Slack channel announcements. So we don't send the full list once it's released to everyone, but every team has its own channel and we publish only the meaningful ones for each team, and so that they have their own stakeholders being tagged and mentioned there. An important piece in all this is actually engineers need to make sure to follow this format for proper filtering and grouping. So we've been investing some time, and actually we finished this a few weeks ago. We have linting in our PRs. So if this entry is not correctly formatted on pull request, we would actually block the pull request by using danger. And this actually allows us to prevent having bad formatted release notes and maybe issues on the pipeline. So actually, what is the key takeaways of this, right? So this has enabled us to have a constant and precise communication with all stakeholders, and we believe that this is key. So during the release trains, it's very important to keep all stakeholders updated and prevent misunderstandings of actually what is going live and what is not. If by automating this, actually we make sure that there's no delay. So once a change lands on the release branch, 30 seconds later or even less, we have the notes updated to all stakeholders. So actually we can, no one can say, oh, I didn't know this wasn't included. Oh, I thought this was included. This is always updated and is automated. Then stakeholders actually need a single source of truth for information. So one is the Slack channels that I mentioned, which is segmented per team, but we also keep the final changelog and the final release notes in our GitHub release, and so that it's always accessible by everyone. And then going back to the format, we believe that is, and we saw it's very important and very beneficial to have a single way of communication. So by enforcing this single format that is generic, we make sure that if a stakeholder, for example, it's looking into releases of separate teams, they receive the information in the same style and in the same format. So actually there's no confusion and different variations of how to communicate internally within the company. For this second part and the internal part, we actually use Instabug and Slack. So actually part of all this communication also goes through Instabug through bug reporting. So during the freeze of the 48 hours and during the entire week, this is not limited to the 48 hours, every employee can actually just take a screenshot or shake their phone on Android and upload a bug report to our system. And then we would get notified, and that would we can get a ticket created and everything to get it resolved. And then, as I said, we have one way of announcing things, but we also have a way internally to notify about incidents on Slack. So that's more or less for the generics, and I'll go now briefly into actually what are the platform specifics, because this looks very good, but actually there's quite a bit of differences that I don't like to say so, but puts Android puts Android a bit ahead. So as Roldan mentioned a bit at the beginning, as iOS engineers, we need to deal with App Store Connect API, and the App Store Connect API is actually probably one of the slimmest APIs I've ever tried to work with. Actually, once we were asking part of the API team at Apple, we're requesting features that actually we needed, and they were noting, I think they were just noting in the list of things I'll never do. And the API is super, super, super close. So actually, I'll go into the tooling later, but we use Fastlane to work around this. So actually, what are the pain points on App Store Connect, right? So App Store Connect, we don't have release management options through the API. We don't have any signing related options through the API, so we cannot sign the app or create provisioning profiles through the pure API of App Store Connect. And also there's no phase rollout for real. So the phase rollout is actually only for automatic updates. So if any new user, or if me as a user, I go and manually access our page on the App Store, the app is directly downloaded from the newest version. So this is not like Android. Android actually has separate binaries in production, let's say. So different users will see different app versions. On iOS, if you go to the store, everyone sees the same version. The phase rollout on iOS is only about when Apple decides that your phone is going to update this app nightly. Then also the reviews. So as Roldan mentioned, the review time is inconsistent. We can still estimate it between 24 and 48 hours. I know that recently has gone down to a couple of hours, but to be honest, I'm not a huge truster here. I've seen different. That's something still that we need to wait in our process, and also random rejections. So all of you here that work around any iOS app, you know that probably you've had some code already live that you think it's compliant with the guidelines, and then suddenly in a review you get something that is not compliant. It's not only about code. Like, to be honest, about code, we didn't have any major guidelines rejection for quite a while. I would say a year or more. But we had about screenshots, about description of the app. Like, we're getting new rejections with time, which even if we don't want to, it adds some delay, because then we need to resolve and discuss with them and everything. And then hotfixes, actually, we're not able to hotfix, as Roldan mentioned, in a couple of hours or minutes. Hotfixes, what we do is we submit an expedited review request to Apple, but it's actually up to them to accept it. And it's actually disclaimed that they are not forced to accept your expedited review request. So we might have a hotfix that we need to release. They don't think it's reasonable, the explanations we're giving them, and they might reject it, and we might need to even wait for the 48 hours. Usually with expedited reviews, you would get this couple of hours review, or maybe even 1 hour. We've seen expedited reviews going within an hour of review, but this is again, in Apple's hand, is not in ours. So we need to wait this in the worst case scenario. So as I said, current review time is 1 to 2 days. I would still consider that, even Apple has been improving a bit. And then these are the phase rollout values from Apple. And another pain point is actually we cannot modify this. So when you go to App Store Connect, you can actually not modify what values you wanna have. So these are the default values. Apple does a weekly, 1 week phase rollout. But as Roldan explained before, we actually wanna force it on Thursdays. So on Monday we want 1%, on Thursday we want 100. So we planned about having a more, I would say, harmonic growth on the percentage, but actually we cannot do so. So the only thing that we can do is on Thursdays force the 100% by forcing the release to all. That's the only functionality the App Store provides. So we would go from 1 to 5%, and then on Thursday to 100%. So we really need to make sure that from Monday to Thursday we catch any potential issues, because there's the spike is big in terms of automated of phase rollout. It's also true that, because I said this is only for automatic updates, on iOS we do see pretty higher adoption than just this 1 to 5% in the days prior to the final release. And yeah, that's basically dealing with Apple. So on tooling, as I mentioned, how can we actually work around this? So we use Fastlane for all the automation part. Fastlane actually allows us to sign the application and allows us to upload it, submit to review, cancel the release, force the release, all of this that actually the proper API from App Store Connect doesn't. The only thing we use the App Store Connect actually for is to manage and modify and publish a release sometimes manually, and maybe manage what users, what developers can actually have access to it. And then we rely on Travis, as we actually need Mac machines to do all this work. We have Jenkins as an orchestrator, but we use Travis as a slave of Jenkins. So we just use it as a pure machine that we spin up, we compile maybe the App Store version, push it to the App Store, and we kill it. There's not more logic in there. And then for Android, there's not much to say. So Android actually has instant publish. So actually apps can get published instantly without any delays. They have fine-grained, as I said, fine-grained control on stage rollout. So actually they control exactly the percentage of users that this stage rollout is targeting. And then they can actually halt releases for real. So one thing that actually I didn't mention on iOS is the same way that we cannot control having 2 versions. If we pause a phase rollout, we're only pausing the automatic updates. So you pause the phase rollout, but you go to the App Store, you will still get the new binary. So to keep it simple, Apple only holds 1 version of your app at any time. On Android, they actually can have this power, so they can actually halt releases and prevent this from spreading more. That is something that we cannot do. And also on Android, they have the Docker file defined by developers in the repo that they can change without the platform team. As we've been saying, that this is a huge benefit for us because the platform team is pretty narrow and we keep growing on mobile. So now I'll leave it back to Roldan for him to explain how we can move forward with this.
Can you see my screen?
Yeah.
Thank you, Mauro. Let's move to the what are the, I mean, we explained where are we now, and just some ideas that we've been evaluating to keep improving all of this, because also the improvement process needs to be improved. So first, we would like to change our internal distribution tool. I'm going to be honest here. We are using App Center now because Microsoft bought Hockey App, which is the tool that we were using. That's the only reason why we are using App Center. The migration was not super cool because at the beginning, the SDK, I don't think it was fully stable, at least in Android, and it has some issues, but now it's stable, but still we are not super convinced about this. So we are thinking about other solutions. In iOS, probably it's going to be an in-house solution. which probably is going to be easier and cheaper to maintain, and it removes a dependency on an unreliable provider. For Android, we are thinking about using the beta program in the Play Store instead of this for two reasons. First, because in this case, we would promote the same artifact that has been in beta, we will promote it to production, as opposite to what we are doing with App Center, which is having two different artifacts. And you know that usually in theory, it should not happen anything, but if you compile the same thing in two machines at different times, issues might be introduced. And that's the first reason. The second is that, as in every probably tech or startup company, there is a lot of more iOS employees than Android. So the actual testing that we have from internal employees for Android is not as good as for iOS. There are a lot of bugs that are caught in iOS, and then we realize that it's also happening in Android, but just no one ever reported. Besides that, we also want to increase the build time in both platforms. I think now our CI/CD takes about 20 minutes to run in the pull request. So it's 20 minutes that the developers are waiting to complete. So there are several things to do. In Android, for example, we started some time ago modularizing the monolith, because both applications, both Android and iOS, were monolith. We are modularizing inside the own repo. But in both platforms, we're also thinking in extracting parts of the code that can be reused in different projects. As you might know, in Glovo, we have the customer application and we have also the courier application. Both applications are different and they are released at different times. They are also they follow different process, but they are using the same library because they have different requirements for doing the release. But we have these two applications, and currently we are not sharing any code. We are sharing knowledge between developers, but we don't have shared libraries. And there are certain problems that we are solving in both platforms. And one of our ideas is to split this monolith into libraries that can be consumed by all. This in one hand will reduce the build time, and in the other will have more. If you have more apps using the same code, of course, it's going to be better. Also, I mentioned before, but I want to stress and highlight again, we focus a lot in UI testing because honestly, we need it. And now is the time for UI testing. For now, we have just the login, but we want to complete and to follow the paths. I'm going to take the chance to answer already one question that was regarding to this. There was one question regarding UI testing. If we are doing, or if we have a Q&A doing it, we don't have Q&A team. The philosophy in Glovo is that everything owns their own process, everything end to end. Since the moment that the feature is analyzed and done until the moment where you need to observe and to monitor this in production. So we don't have any QA team for anything, and it's the teams themselves, the ones that need to do all the UI testing for these features. And maybe we will introduce screenshot testing. We don't know, we are evaluating what will be the next testing, but now we think the kind of testing that is going to provide more value for us is UI testing. Also the Slack bot that Mauro was mentioning. It will be super cool that instead of asking to us or going to some critic channel that only developers are, anyone in Slack could just type a command or write with the Slack, or what is the current release? What are the release notes in this release? What is the current rollout? And for developers, if you have enough permissions, it will be cool just from the Slack when you receive all the other alerts to have the chance to have the release or create a hotfix or whatever we want to do with the Slack bot. This is also something that we are evaluating to do at some point. And last but not least, I think this is the more ambitious one. We have everything automated, mostly everything automated in this process, except the error handling. We have observability in place, we have monitoring others, etc. But we don't. But all of this end up in manual, in human interaction. So we were thinking about different ways, and as we were mentioning, we have two cycles. We have first the beta, and if the beta is stable, we release on Monday. So why don't check the status of this beta? Why don't check if we have bugs or the crash rate drops from a certain percentage, and just stop the release and jump into human interaction? And in the other side, for once the app is released, we could, if we detect critical metrics drop or a crash ratio drop, just halt the rollout. Just stop the rollout and create the hotfix branch and notifies to an engineer to see what happens. Maybe the engineer will just continue the rollout because it was not as critical, or maybe just write a hotfix. And even more ambitious, instead of just halting the release, why don't linking metrics or stack traces into feature toggles that we know that are related to a certain feature? This way, if we check that the metrics are dropping, we can change the feature flag and just stop the issue. As I say, all of these are just some ideas that future thinking, things that need further investigation, but all of this might make sense eventually. And that's all from our side, or the presentation. I hope you enjoy and that it was not so boring. Let's go to the Q&A that we were saying before. I think there are 17 questions. We can go in order by votes. So maybe you, Mauro, want to also remove your micro and we can talk both of us or something like that. So for example, first question is from Gail. Do you have regressions before each release? I'm not sure if you mean regression test or regression bugs, but every time that we solve a bug, every time we have a hotfix or any kind of bugs, we try to write test to make sure that this not happen again in the future. Of course, this is just up to the developer, and sometimes it's not easy to write a test for these things, and sometimes this might not happen. But I don't remember having many regression issues in the past. Sometimes, of course, it happened, but I don't remember happening it so much in the past. Mauro, you want to add anything about this point?
No, I think you covered it.
Oh, wait, I need to move.
Sorry, I think they are meant to regression test, the practice of having a QA that does a regression before a release. And as I would say, we don't have the...
Yeah, we don't have to.
We don't do manual or smoke test or regression test manually before,
Yeah. I mean, every team should control the releases. So if they should be testing manually some of the stuff before actually opening the PR, but we don't have like a set in stone process before we release. So I'll answer the next one for iOS. For iOS, when you mention that you release a version, in which moment you are merging the release into master? A, when you send it to the Apple for review, or B, when you click in ready for sending the App Store Connect. So as I briefly mentioned, but just to clarify, we do that on Mondays after we've pressed the button. So we press the button to release, press the button we use, as I said, we use Fastlane. So once we run the correct stage on Fastlane and everything has gone well, we do the same stage on the Jenkins pipeline, executes the Git flow strategy to merge back to develop and master. I assume that with all my explanation, maybe that's answered. Do you want to pick the next one, Roldan, or should I continue?
Yeah, as you want. Oh, wait.
Okay. Yeah. So I see. What?
Now is how big are your teams?
Oh yeah. I see that they're changing. Okay, cool. So yeah, how big are your teams? How many teams per platform? So I get this question usually, and I always try to count. So in terms of, Glovo is structured in squads. So we have different squads within the app. So not all iOS developers for customer app, for example, are in the same team. For example, the three of us here work in the same team. So we work in the customer experience team, which is actually one of the teams that works around the customer app. But in our team, we're 2 iOS developers out of 9 or 10 iOS developers that work around the customer app. And then there's also teams that work around the courier app. So the exact number with exact figures of how many iOS developers and maybe how many teams, I can try to come up with. I don't know, Roldan, if you have it more in mind, like how many mobile developers you have per platform per app. But
we are like, I don't know, like 12, around 15 iOS developers and 15 Android developers, more or less.
Yeah, I so yeah.
I don't know, like 10 different teams. They're feature teams. They have specialized domain, as Mauro was saying. In average, 1 or 2 developers in it.
Yeah. Something to add to that is that we don't have teams per platform. We have teams per domain.
Mm-hmm. And these teams are fully equipped, let's say, with iOS, Android, front-end, back-end, product manager. So they are completely independent.
So how long does it take to do a full regression of the code, and when you do it? I imagine this a full rollback, maybe it means. I don't know if Bene can clarify. I can give you voice access, Ben, if you want to say something. I just give you talk access.
Hello?
Yeah.
Do you hear me?
Hey.
No,
Yes.
I was questioning myself that if you have some kind of process where you will say, okay, I'm going to pass all my set of tests that I have, all the integration tests, everything, all the tests that you can have in your app or apps, and how much time does it take, and how long or from when do you usually do this, if you do it? Is that?
So all the tests, I mean, we don't separate between regression tests and regular tests. For us, everything is automated tests. So as I was saying, if you have a bug of something, you have a test in your unit test suite, and that can count as a regression test. So we run all the tests or automatic tests for every pull request before being merged. We run all the tests after it's merged, just to make sure. And also in the release branches, before doing the release, we also run the test. So actually, before doing the release, we run again all the tests, even the UI test, to make sure that everything is all right.
But what I mean is that I suppose the UI tests take much more time than your unit tests. So I don't know if this covers much time or if it's enough for the developers in order just to wait for all the tests they are executed after a pull request is launched, if they need just to wait for a long time or not, in order just to merge.
Yeah, the UI test is not running in the pull request actually. So yeah, as you say, UI tests usually take more time. So we have a nightly build for the UI test, and we also run them after any commit in the release branch. So after the pull request is done and we have the merge there, we run all the UI tests in that moment.
Thanks.
Yeah, and for the unit, just to add on it, and on the unit tests, yeah, we run them. You ask about time, like roughly. One of the reasons why we're looking for in future maybe to have some precompiled shared modules is actually trying to decrease that, because compilation times depending on the machine. And there's a question I'll dig a bit deeper later. I saw a question about MyStadium. Actually, on iOS, on the customer app, it takes us around 30 to 35 minutes to run the unit test suite, which is quite a lot of time. And I'll share my experience. I'll share some fun experience later when I get to that question.
Cool. Next one, Mauro, is iOS.
Yeah. So actually, I read it. I'll read it for everyone. So why not using Firebase for bugs in iOS as well as Android? Which features are missing from Firebase that you have to use another tool like Bugsnag? So actually, as we mentioned, we have Datadog as our observability platform widely for the entire company. Datadog is actually currently working on a library to track crashes themselves and provide observability on mobile. They don't have any pure mobile SDK to provide context and observability around what's going on in the app. When we were analyzing how to feed that, because we want to have this crash information on Datadog, we were looking at Firebase. That was the tool we had. So we actually had Firebase with Crashlytics. So we analyzed it and we actually saw that there was no way to forward that information from Firebase to Datadog. We did look into BigQuery. We did look into several solutions. Actually, some of them even claim that it could take up to hours to get it. So we need live reporting, because we also have alarms for our on-call rotations based on the Datadog metrics that we have. So one of the engineers in the platform team actually suggested to use Bugsnag as a preventive measure to actually get the data in Datadog until we wait for Datadog to release their own crash reporting. Also, so that we could send, Bugsnag allows you to get a callback every time it's going to send a report to their systems. So we are able to, at that point, send a new metric to our Datadog dashboard saying that we got a crash. And on Android, this is not so critical, for example, because they can have multiple crash reporting systems. On iOS, it's only one. So the first one that gets it takes it, right? So the stack trace, for example. So we needed to switch to Box now. To be honest, so far so good. We didn't have any major issues with bottleneck, and it does the job. But to be clear, the roadmap is actually to switch fully to Datadog on this. I hope this answers your question also. And I'll let for Roldan, I think you know the next one.
Yes, backend releases. So backend is doing multiple releases per day. So we don't get aligned with them. So the idea is that all applications will be completely independent on how backend do the releases. That's one of the reasons that we use feature tokens a lot. So we sometimes even if we do weekly releases in mobile, sometimes we finish earlier the clients than the backend. So when this happens, we release all our code behind a feature toggle, and once backend is ready, or triggered by a backend request. So once backend is ready, the clients can consume whatever. So we try to be as independent and separate as possible, and it is the only way. There is no other way to work, because backend is going always to have different release cycles. I mean, backend can do 100 releases a day. No.
I mean, I was marking others. I don't have anything to add, to be honest, on the backend part. You just covered it. So I was grouping a few. There was one that was there actually around Mac Stadium. So do we use Mac Stadium or on-premises Mac Minis? There was another question around. Let me find it. Actually, yeah. What is your build time per app, and how do you plan to modularize it? So I'll be short on this one. As I said, we use Travis. We tried GitHub Actions last year on December, and it reduced our build time from 30 minutes to 15 with no code changes. By analyzing this, we saw that both Travis and GitHub Actions were using Mac Stadium under the hood, and probably GitHub Actions is just using some more fully equipped Mac solutions, or Mac Minis or Mac Pros from Mac Stadium. So actually that already benefited a lot of our build times. So as I said, we're gonna invest time in modularization and pre-compilation of components, and using dependency managers, probably SPM once it has binary support, or CocoaPods in the meantime, whatever, or Carthage to reduce that. And we do have a roadmap to move to Mac Stadium at some point, but we need to do this in steps. And as I said, the team is still not that big, but we do want to get rid of Travis, because also Travis doesn't scale in terms of jobs that we have at the same time. Yeah, I think that's it from my side. Maybe, I don't know, guys, what do you think? Maybe, I don't know if you have anything extra with this. Maybe we can move with Guillermo's part, and then maybe with more questions that we get in his talk, maybe we can move into answering all of them if there's any left.
Yeah, I think it's perfect. I just want to address one last one before moving, because I thought it's quite interesting, which is, how do you handle when the automated branch cut, someone come and say to wait because they are finished something, and product is putting pressure to go into the next release? Let me answer this one, because I think it's pretty interesting, and just move to the others. So the best solution here is training the product managers and training the developers to change your mindset. So if you are having random releases, or you are releasing once per month, it makes sense to delay everything, because a feature must go live. If you do weekly releases, you shouldn't have this problem. I don't think there are many releases, many features that are super business critical. And Mauro was mentioning this, that we have the builders and deploy system in place, but at the end, you just need to change the philosophy and the mindset that you have a release cycle, you have a weekly release train. So you just need to, your minds will be just, I merge into develop, this will eventually go live, and it's okay. And most of the time, we're not going to have any loss of business because this is 1 week later or the other. I just wanted to highlight the mindset, because we have this discussion several times, and at the end, you just need to change the way of thinking about when something is done. Something is done once it reaches develop, because you know that it has a fixed release cycle that will arrive next week. And
so yeah, I would say we can move into Guillermo's
yes. let's do the Guillermo talk, and if you have more questions at the end after Guillermo multi-platform questions, we can jump back into this one.
I think we can. So anyone may leave later. So if they're interested in the question, they can just stay.
Yeah.
Okay.
So
I think I should start sharing then.
Yeah, you just heard.
Just one last note. We have a form with some basic questions about how do you do a continuous deployment and delivering in your companies. I just shared it in the form. There are also a few questions about Kotlin Multiplatform. So maybe it's wise to wait until see the Guillermo presentation. But if you are going to leave, I just sending here in the chat the link, so you can answer the form.
Perfect. So let me know when you are. You can you see it, the screen?
I see your screen, Guillermo.
Great. So this is the talk about how we use Kotlin Multiplatform to solve a business problem, or based on the business need. So first, let me start with myself. I'm Guillermo Mazzola, an Android engineer here at Glovo. I work also with Roldan and Mauro in the same CX team, and also my social networks. Either I don't use Twitter, but I have Twitter anyway. So the story started with once upon a time. So what is the big, first, let me introduce first what is the big picture of the problem we try to solve. Here are some facts about Glovo. Glovo is a data-driven company. We have, as the guy says, two main apps in the over there. The courier app, which is the one that the courier uses, and the customer app, which is the one that is available in the store for anyone to download and use it and order. We also have, as you also mentioned, distributed teams. Each team is independent from other teams. I mean, they have their own way to work, their own PM, their own backlog, and they are also contributing to the same source code. And we, as any data-driven company, we have a data warehouse that stores all the information that we generate. So the case of study, tracking events. Basically, this is how we solve this problem that we have with Kotlin Multiplatform. So let me explain first what is our Kotlin flows to doing tracking in our apps. Everything starts with the business need. So basically a decision needs to be taken, or a new feature is released, or just we want to understand the behavior of the user. So there is a business to understand that. So a change request is put. So they ask us to, I don't know, if we want to check the behavior of the user when he is on the order screen, they ask us to add some events or something to actually can start measuring that. Then those changes are implemented in the apps by developers. Then the app is released, as we saw before with the presentation from Roldan and Mauro. And at the end, new data starts coming into our pipeline process for data, and it ends up in our data warehouse. So before, a few months ago, we did a meeting when we have some assertions regarding this current process. The first problem we find out is that the platforms produce slightly different data for the same tracking event. There is a need to have a unified catalog of tracking events, because right now no one is sure of what we are tracking and why. We have a poor coverage on how we generate that data, and we don't know exactly what events are actually getting sent by which platform and what are not. So we don't know the current status of those events. So based on that, there was an outcome of that meeting, and we have defined the following action items. First, we need to create a tracking spec, and a way to have a unique way to have a definition of the events itself we want to track. Second, we must assure the data consistency between all the platforms. And by platforms, I mean not just mobile, I mean web, iOS, and Android. And we should cover with automated testing and real-time monitoring everything we can. So now we have our key points from that outcome. So the first thing we decide to do is to start generate YAML specs, use YAML to have the spec definition, and that will contribute to have to unify the difference between the events. For instance, with this there is no reason right now we have an attribute of the tracking event with lowercase and the other another platform is uppercase or something like that. Having a spec, we also allow us to have a unified catalog because we have a spec, so all the collection of the specs will be the catalog. And it will allow you somehow to have a live implementation of the status of them. We also decide to use code generation to reduce the possibilities or the chance of developer introducing defects on the events. So if we can optimize how those events are getting sent with code generation, we will actually contribute to those goals. We also decide to add versioning metadata, and this is exclusively done to, in the future, hopefully we can provide a live status of the event itself. So we have a version embedded in the code generator. We can start tracking when this actually code is getting in production. And last, we defined, we say we should start doing observability and increment the number of tests on it. So we can actually provide, increase the quality of the data that we generate and also provide live status. So at this point, I already tell you, but you may answer if you are going to talk about Kotlin or not at all in this presentation. And the answer is yes. So I'm going to go with that. First, we define, this is like the overview of the talk. First, I'm going to talk about our multi-platform library that we have created, which is going to focus on this part of the workflow. So how we handle change requests and how we implement the library, we will take part on that part of the process. So how is the column workflow affected? So any change request, we imply that we should update the spec. So if we want to introduce a new event or we want to change the signature of the event, we should update the YAML spec of that event or create a new one. With that, we will generate the code that is going to send the events with Kotlin. We will generate Kotlin code based on the YAML spec. Then we have a base code that is going to get combined with the event generator, and that will produce our multi-platform library. That, at the end, is going to be consumed by the Android app, the iOS app, and the web app. So, some code. This is an example of a YAML spec. It's pretty easy to understand. Basically, we declare what platform we will be using it. And then we have an entry per event, which declares the type, a name that is going to be the name downstream, I mean, the name in the data warehouse, and the parameters and the type of those parameters. So with that spec, this is the Kotlin code that is getting generated. This Kotlin code, because we are using Kotlin Multiplatform, it can be used at any platforms. For instance, in Swift, this is the way we will consume this event generated in the YAML in a Swift code. So you can see here how the code in the YAML it start to be the same in the Swift code. Seems to be simpler, the solution, but you can tell the base code of this is pretty much high. We've been working a lot on this solution, and I will explain later why. So let me go to the section of challenges and restrictions, because this is not so easy as it sounds. First, I want to state some facts about Kotlin Multiplatform. The first question is, it works? And the answer is yes. So did it works? And the answer is, okay, yes, but there is some restrictions. The first one is that it requires a shared repository. I will explain later what this means in the next slide. There is no Swift or TypeScript support. So even if it works, if you want to do the interop with native languages of the other platforms, the integration is not so great. And we cannot produce a native library. So at the end, any web developer or any iOS developer has to know something about Kotlin. So what do I mean by a shared repository? If you go to the official example for multi-platform in Kotlin, you will find this layout. So you have your multi-platform library, but you also have to have the Android app and the iOS app in the same repository. So this is not the case in Glovo because each app has its own repository. And if I want to propose this to merge all the repositories into just one, the answer obviously for all the teams will be a big no. So this is a big challenge for us and a big restriction to achieve this. And so as I mentioned, if I propose or you propose in your company to use Kotlin Multiplatform, you should know that at least at the moment, and at least I'm not aware of another way to do it, you should have a shared repository for all the consumer apps. And the developers from other technologies who have to know something about Kotlin because it's not so straightforward to interop with those languages, and you don't have native support. So what we do here is to, okay, what if we do have native support from Kotlin Multiplatform? So if let's assume there is a way to publish native libraries from Kotlin with Kotlin Multiplatform, everyone can keep its own repo because they will be consuming the native libraries that we produce. So they don't know, they don't have to know that library was written in Kotlin at all. For them, they will just consuming a CocoaPod or an NPM library for web. So the question now is, how do we do that? And now we go to the third part of the presentation, which is the tooling we build, and that's the reason we have so much lines of code. So tooling. First, to understand this project, we need to know what is the Gradle Maven plugin. I am assuming that everyone that has played with Gradle or with Maven knows about how to publish a library. And basically the way you do that, even with Kotlin Multiplatform, is to create a Maven publication that will create the POM, and it will publish the shard into Artifactory or Shade Center or whatever. So the first thing we did is to basically create a plugin dedicated to CocoaPods in Gradle that has the same architecture that the Maven publish plugin from Gradle, but it's for publishing CocoaPods. And we did the same for NPM repositories. So then we took the Kotlin Multiplatform plugin and we extend that functionality to merge these all plugins together into our Glovo library plugin, Multiplatform library plugin. That basically, the main goal of this is to allow you to publish native libraries instead of publishing Maven libraries from Kotlin Multiplatform. So let's take a look at how the official Maven plugin from Gradle works. This is a simple implementation of if I want to create a Maven publication, which is already done by default by the Kotlin Multiplatform plugin. But this is the way you can create a Maven publication by your own. Basically, you apply the plugin, you can then declare repositories for it, the type of Maven, and then you create a publication with the create method, and then you set up the POM and all the attributes of the POM, which is the descriptor of the Maven publication. So for CocoaPods plugin, the one that we made is pretty much the same. So you apply the CocoaPods plugin, then you can declare CocoaPods repositories, which is by default the CocoaPods spec from CocoaPods. Or for instance, you can use your own private repository spec as we have in Glovo. And the configuration is pretty much the same. You create a pod publication, and then you can configure the post spec with whatever you want. For instance, declare a post spec dependency for your project. And the same applies for the npm plugin. You can refer to the npm repository for publishing, or publish to a local repository, or the GitHub npm repository, and create a package publication for that, and declare dependencies, for instance. So now let's see what is our multi-platform library plugin doing. So first, the first feature it has is that it declares a new target in the Kotlin Multiplatform plugin, which is based on the JavaScript target, but also as a tar.js task that is basically building packaging your compiled JavaScript code into the NPM package specification, and also as a package NPM publication, so you can, with just one great task, build and package and publish your native NPM package into NPM repository or whatever. So this is an example of how the code will look in Kotlin in the Kotlin build script. So instead of declaring a JavaScript target, we declare an NPM target, and that will be all. The second feature is that we have a pod target, which is based on the iOS target from Kotlin Multiplatform. As it's based on the iOS target, it also aggregates the architecture-specific target from iOS, and also as a FAT framework task that is going to combine all the targets into one single framework, so it can be consumed by any architecture. And also as a publication to polish that FAT framework into the postspec repository. This is how it looks, and again, we'll replace the iOS target with the pod one. A small tip here: if you didn't realize yet, in the latest versions of the Kotlin Multiplatform plugin, they have created this iOS alias to use the configuration of declare edge target specifically. So you can just use iOS, and that will be an alias for the architecture for the iPhone and the architecture for the emulator. The third feature that we add in this plugin is a standard layout extension. So basically, we expose a new subclusture into the Kotlin cluster, which enables your grade model to convert this model into multi-platform library, and create on intermediate subset to share code between the targets. I will explain this in the next slide. So this is how the DSA looks like. You can declare either your project will be an Android one and a mobile, an iOS one, and will be targeting web and can be targeting backend also. And just for lazy ones, we can replace this with mobile, and that will imply internally that we are declaring that this is Android and iOS. So what do I mean by standard layout and source and intermediate sources? So if you have worked with Kotlin Multiplatform before, you know that you have the common main source set that the code that you put there is going to be available for any target. And then you will have a source set per target that has all, in there you should put all your actuals and all your platform dependency code. So with this standard layout, what we are proposing is to have a JVM intermediate source set, and backend will use it. So any class that we put there in the JVM will be for use in the Java virtual machine code, and it will be available for backend and also for Android because they both use JVM. We also are creating a client source set that will be used by a mobile source set, and that will be used by Android. So iOS, we share classes from the mobile source set and the client source set. To finish, web we use classes from client source set. So with these combinations of code, You can decide where the code that you are writing is going to be available for each of the platforms. And you can play here with the actuals and the specs also from Kotlin Multiplatform. And to finish this, the same configuration applies for the test sources. Okay. So the last feature that we have built in this multi-platform library plugin is the URL file publication support. It's hard to understand now, but I think it's going to be clear later in the next slides. So basically what this feature, what it does is to have in your pod publication all the modules and the types that are in your code and in the transitive dependency code declared in the API class path will be exposed in the header frameworks. Basically what this means is that you will still be able to access this from the interop, I mean from Swift code. You will be able to access the transitive dependencies from Swift code. Otherwise, only the classes that are defined in your project will be available. Pretty much the same, but for different reasons, happens with the npm package. So we have support for building an npm package that's going to have embedded all the dependencies that are transitive by taking advantage of the bundle dependencies feature from npm. And as I said, we want to focus on this, on the lesson learned of this project, which is the next slides. So this project was motivated by solving a business need, but it also helped us to have a quick understanding, a lot of lessons that we have learned during this project. I would like to share with you, and that's the motive we are having this presentation. So first lesson learned, transitive dependencies. We have, as I said before, we have a multi-platform project. This is how in a regular multi-platform project, what is happening. If you declare Android target, it will create a Maven publication for that target. If you declare iOS native target, it will create also Maven publication, but instead of having a hard artifact, you will have a Kotlin artifact, which is basically the live compiling for the native. And if you declare a JavaScript target, or the Kotlin Multiplatform project plugin will also generate a hard, but instead of having that class files inside, you will have JavaScript files inside. And all of those artifacts from Maven will also depend from the common one. So this is the standard configuration that you have underneath when you use a standard, not ours, a standard Maven, a standard multi-platform project. So when you publish a hard from your multi-platform project, make sure that you also publishing the hard from the common source set also, which is the Kotlin metadata. Otherwise, it won't compile, it won't resolve it, because it has a strong dependency on it. I mean, the POM from the main artifacts depends on the artifact from the common artifact. So everything was working fine for us until we decided to do this. As we have two apps, we decide why we will be having all the events in the same project if we can split it. So we did that. Now we have a common multi-platform project with a multi-platform module in the same project, and also we have a courier multi-platform project which depends on it, and we have a customer multi-platform project which also depends on it. Everything works fine, but we've had issues, and I will explain now what happened. So compilation works, everything works, and if you run the code in console, everything works and it's fine. If you publish also, okay, it works. But the first problem we face is that there's no way right now, at least I try to research it and I cannot find a way to get it to work, is how to share tests between the modules. You can share the You can share the code between in the main application, but in a regular Java application, you will have the text feature plugin, or you can create your own test artifact. But for Kotlin Multiplatform, it doesn't work because of the complexity of the Kotlin Multiplatform itself. By the way, if you didn't see this plugin yet, I encourage you to look at it, because this is the great way to have an artifact for tests in your project, in a regular Kotlin or Java project, to share to have the test artifact shared between multiple modules. So again, going back, maybe publication was fine, nothing was broken, and everything was fine. The problem is that the publications that we have made with the new plugins was not working as expected. So what was the problem? I'm going to just drop customer, because let's focus on courier, or customer is the same, they both have the problem. So we built the project, the library, we published the library, and everything was okay, everything was received, it was published, but when we were about to consume it in the either Swift or the web app, we realized that all the code that was in common was not there. This is not happening on Android because Android is using Maven, and Maven has the native way to handle transitive dependencies. But that's not the case for NPM or Cocoa Pods, because we are not actually doing that. And that was, that was a big problem, and we need to solve it if we want this project to work. So if you remember, okay, this was the how it's handled by Maven, and that's the native way to do it. So Android was not the problem, because the native way is to use Maven. So how we handle the problem for NPM and Cocoa Pods builds? I mean, the right approach feels like you should have native transitive dependencies as well. That means that we should publish for the common module a Cocoa Pod also, an NPM also library for the common module. It could be an option, and we actually try it, but then we realize that there is some conflict with the native, with the Kotlin native, when you declare multiple times the same types. So even if we have the types in the common framework that it was in Xcode, we have the type from Kotlin there, and we have the types in the courier or customer app. They seem not to be compatible between those models, because it's like they were two totally definitions for Kotlin native. So I didn't research, but I read some changelogs from the recent versions of Kotlin, and they have to been addressing this problem, but honestly, I didn't try it. So it maybe fixes this problem right now. So the other approach was, instead of having publishing the transitive dependencies for the project, what we decided is to, what if we bundle the project into one model? It's not ideal, but at least it was working. So this will be equivalent to have a jar with all the dependencies bundled inside it. So we did that for Kotlin native. The way we can achieve this is to call this internally. When you configure the binaries, you can expose some modules, and that will imply that the headers will be writing, so you can actually access them from Swift interrupt. And for Kotlin JavaScript, as you say, the way we decided to do this was to use the bundle dependencies. Basically, what it means is that in your package, the one that you later publish, you will have all the dependencies inside the package, the ones that you want to share. So we decided to go with this. And that will be the 4 features that I mentioned before from our multi-platform library. Okay, to finalize this, we have a few lessons learned regarding Kotlin native, and I would like to share with you. So first, how is the memory management in Kotlin native? So everything was fine. We built the library, we tried, and we realized it was crashing after we do some navigation on the app. We are not sure why. So after researching, we find out that the memory management in Kotlin is not the way we expect to be, and they have reason to be like this. So basically, any object that is created inside the Kotlin native, it has to be either mutable or global, but it cannot be both. That means that if the object is mutable, it means that it can only be accessed or modified by the thread that has created it. So it cannot be used for any reason in another thread. And if it's global, it means that your object and all the graph that the object, your object reference, it should be frozen. That means that it cannot be changed. So to make you understand, this is a quick example of why this is not going to work. So let's say that we have a main function that creates a list, and then we create 10 or whatever number of threads that they are going to add a list to the item. If you try to run this code, even if the list is thread safe, it doesn't matter. If you try to run this code, you will get this exception. And this actually means that we are trying to access an object that was created from a different thread, and that object is not frozen. So we have this issue. So we could say, okay, what happens if I froze? Oh, sorry. What happens if I freeze the object? Okay, if I freeze the object, then the object is freeze. It means that it cannot change. So then I won't have that exception, but I will have this another exception, which also basically means that I have frozen this list. I cannot change it from any thread, this thread or any thread. So at this point we were blocked, and we say, and the question that we have now is, can we have actually, how will handle if I need to have a list that is going to be, I want to be mutable, but I want to be shared by multiple threads. Is that possible? So the answer is yes, it is possible, but it's not out of the box yet, at least from my research. Maybe I'm missing something. I was digging around into the Kotlin Lang Multiplatform channel. Some guys have, I know that is some other companies working on having some kind of backport of the Java stack into Kotlin Common that will address also this problem. But at the moment I tried, they were not supporting JavaScript, so it was not a good fit for us. So at the end, we have to go with our custom implementation. So how do you handle mutable and global? Basically by taking advantage of the atomic reference and a custom implementation of mutable list. So this is a draft of the code that we have. Here you can see that we have declared a native mutable list that implements the interface mutable list and has a reference to an atomic reference, which is the list. So the key part is how to handle mutations of the list. For instance, for the add operation, what we do is to use this compute and set for the atomic reference. And we provide a lambda that will tell, okay, based on the current status of the list, this is the way you should transform into a new list that will represent this operation. Basically, I add to the list this element. And this compare and set method, what it does is to iterate and comparing the current state with the list is the one that I expect. And if it does, I replace the result of the transform operation, which is the lambda I was talking before, and I freeze the object so it can be shared. So basically, now we have a list that it can change. It is mutable because it has a contract, a definition for all the mutable operation. It can also be global because everything here is frozen. Because of those two conditions, it means that it's also thread safe because it's mutable and global, which is the reason that the memory management in Kotlin native it is designed like this, is to everything be thread safe. And now we have a working list, which was our need for the native implementation. Another note from the Swift interop for Kotlin native. Yes, Kotlin you can use, as we saw, call Kotlin native class from Swift. it is possible, but it's far from perfect. Here are my notes. I mean, we don't have Swift code. Kotlin compiler does not generate Swift code. What it generates is Objective-C decorated Swift code. So if you open the definition, you will see a lot of Objective-C that is hard to see and follow. And they have some annotations to make it look like it's Swift, but it's not. You also won't have any documentation. Even if you document your classes in Kotlin, you won't have any documentation in the final framework, which is hard for users from iOS to understand what this method is doing or whatever. That's another downside, but it can be improved in the future. And there is no autocast for Swift optionals and primitive types. This is maybe hard to explain without showing you some code, but you will expect that if I declare an integer that is optional in Kotlin, it will translate it to a Swift optional in Swift, but it's not the case. It's translated to in an intermediate object that is Kotlin int, and you have to write the translators by hand, which was the thing we did in the iOS app. So to finalize this meeting, some small lesson learned about Kotlin JavaScript. So what we have learned from the interop between JavaScript and Kotlin.js. First of all, lists are not arrays. Maps are not objects. And I will explain why I say this. So let's say I have this list declared in Kotlin. If I then go to JavaScript, I will expect to have this. So I will iterate on it as a regular JavaScript code. But instead of that, I have this, which for any JavaScript developer that doesn't know anything about Kotlin, and I'm providing to them a native library, they don't have to know anything about Kotlin, this is useless for them. They would expect to have an array. It's getting hard, it's even worse for maps. So let's say I declare a map in Kotlin. I would expect to have something like this in JavaScript, but instead I have this. So this is even worse. No JavaScript guy can actually read this without asking some functions or whatever from Kotlin. So at this point, we were some kind of block. And what we did to overcome this issue is to provide these two helper functions. So here, basically these two helper functions that we have exposed is to convert anything that we have in Kotlin into the JavaScript language. And for the first thing I want to show you is what is the dynamic type. This type is only available for JavaScript, and basically what it means is turn everything time check off. So if you have a dynamic, the compiler don't do any assertion regarding the type. So you can basically go to JavaScript. It's raw JavaScript. The second thing I would like you to note is that what is this JavaScript name annotation? We'll explain why we need that here. The rest of the function basically just iterates the map in a Kotlin way and returns an object in JavaScript with the conversion. So another thing you need to know when you're trying to do some JavaScript interop with Kotlin.js is that Kotlin.js mangles the names of the functions, and they have a reason for that. The first is that JavaScript is a dynamic language. JavaScript does not support method overriding. In Kotlin or any type language, you can have multiple definitions of the same method or function with different numbers of arguments or types. JavaScript doesn't have any of that. So, and Kotlin doesn't produce TypeScript, which will be a great improvement that they will be adding the compiler in the new version of Kotlin. So to overcome this issue, what Kotlin engineers have decided to do is to mangle the names of the function that the Kotlin compiler produced by adding a suffix. I mean, a suffix is computed with the numbers and the types of the parameters of your function. And to be more clear, a suffix is something like this. So if you have a function that is called map or an attribute that is called map, maybe a function, instead of having a definition of map as the function name will be map underscore at the hash. So that's pretty much very hard to maintain for any developer from JavaScript, because the name may change accidentally if I introduce a new attribute, and we don't want that. And that's the reason we have JavaScript annotation, JavaScript name annotation in the code, is to say that this is public API. And instead of do this manually just to support overriding or whatever, just use this function. They just use this name. And I think that's all for the presentation. So thank you so much. Now I think we can go to the Q&A. We have some questions.
Yeah, we were getting a few questions from you for this part, so maybe you can start with those.
Okay.
And then Roldan and me, we've been also during some time picking some to answer later that were pending.
Yeah. Do you know how to?
Yeah, you can go.
Yeah, you should have.
I can read it for you if you want. The first one you have for
yeah,
Kotlin.
I should stop sharing, right?
Yes, you can stop sharing.
Yeah,
The
you have
Q&A.
at the bottom, you have the Q&A button.
Yeah,
If not, Roldan can read them for you.
Okay. What will be now the ones from multi-platform?
The second one from William. Do you have any issues to motivate other platforms developer to contribute in the multi-platform project, as their user languages will not be Kotlin? Is that a barrier?
Well, yeah, I think this is definitely a barrier, because each developer is comfortable working in his own language. So, but I have found some guys that are interested in new technology, mostly for JavaScript, from JavaScript and backend. But even for backend, which Kotlin is fully compatible with Java, they have a lot of resistance to move to Kotlin. So I don't know. Yes, the answer is yes, but I think it will, as this technology evolves, probably there will be more adoption of Kotlin Multiplatform. And that's why we are doing this chat. So you can take note of the things we find out when we try to use it in production. So for you to be aware, just to overcome these issues before any developer face it. So I don't know. I think is that an answer, but I think we can move on.
Are you seeing the questions now? The next one is, have you considered using Flutter or other for multi-platform development?
Well, honestly, I didn't dig about Flutter yet. I don't know if Flutter has the characteristics we were looking for when we proposed this technology, because one of the things we want to solve is how we serialize the data. One of the issues we have with before this is that each platform was serializing the data in the native way. I mean, the two-string way from Swift is not the same that the two-string way for a number for Java, and we were having conflict with that. So we proposed multi-platform because it was the thing I have experience on as a solution. Honestly, I didn't try Flutter. I don't know if we can actually write JavaScript with Flutter, for instance, which was one of the requirements. Maybe we can, but I didn't try it.
From hello, my experience with Kotlin Multiplatform is limited, but I really struggle trying to use coroutine from iOS. Frozen objects are constantly launching exceptions. Do you use coroutines?
No, that's a big depth for us. We also choose a topic that was well defined, which is it was making just classes to send some events. So we are not actually using any feature of other feature of Kotlin, like coroutines or serialization, something like that. So no, but probably the problem you are having with coroutines is not coroutine itself, it's the lack of native collections in Kotlin native. I mean, we have to implement pretty much list, set, and map by yourself because we don't have a native collection that could be safe in Kotlin native. So probably they will add that in the future because if we can create it our own, they should be able to do it. I don't know the roadmap of the Kotlin native support for this. Maybe they have it already. I know there is some other companies that are working on this also, but that's all I know. So we focus on the problem and I'm sharing the experience with you.
Next one.
Yeah.
You got it or already?
Yeah, I can read it. So I saw other teams, some comments. Can you read it actually?
Okay. If you feel better. I saw in other talks some comments where to use multi-platform code in Android was nicer, but doesn't look so nice for iOS or other platforms. What was that an issue to other platform developers and how they react to this idea and this project?
I think that's true. Honestly, it's true. There is a lot. It's a new technology. There is a lot of ground to cover, but it's true. It's not actually producing native artifacts. I mean, the code as we saw, the code for Swift is not Swift, it's Objective-C, and it's the mess. You don't have documentation, so there is a lot of improvement that they can do. But I think they will do it eventually. But it doesn't mean that it won't work. If you put some effort, you can actually get it work. And right now the experience I think is great. It will improve a lot for web to have TypeScript support. Otherwise, they just don't know what is the definition of the functions. They don't know what are the parameters, the types of the parameters. They know nothing about it. They are just without JavaScript. And it will also work if they have, instead of producing Objective-C, they can produce some Swift code that will be also more friendly for iOS users. But again, this is a work in progress and it's evolving fast. So I expect to see this in the next years. I don't know. So what is the new one? I lost
think that was all from multi-platform questions.
Right.
Anyone has more questions, just keep typing, or maybe we can just...
Yeah, you can go to yours and then you can find...
Yeah. We were still missing like 6 questions from the first side. Maybe Mauro, I start with a couple of them that I like, and then maybe you can finish the others. So first one is, have you considered doing trunk-based development and using remote feature tokens instead of Git flow? So yes, we consider, and as part of, I mean, for me, we mentioned briefly this in the talk, but I'm just going to go for more details now. So for me, the strongest point of trunk-based development is not the workflow itself, is the techniques that it introduces. So merge frequently, doing small pull requests, using feature toggles. We are using all of this. So I want to just stop the mindset of thinking that Git flow is not doing all of this. You can do all of this with Git flow. So, and we are using all of these techniques. I mean, we try to always merge quite frequently, doing super small pull requests. I working every day when I check out develop, I try to do my job and commit in the same day. And then the other change from TBD compared to Git flow is the workflow, the actual workflow, the static branches and all of this. So if I think that TBD fits a lot in that aspect for backend, but not for mobile. So for mobile, I think it still makes more sense having the master and release branch because you have really a deployed version and a non-deployed version. And even if not, I mean, maybe if I would need to start a project now from scratch, maybe for mobile, maybe I could choose trunk-based development workflow. But now we have all the setup in place. So we don't see any added value to starting using and migrating everything and rethink everything for TBD. That's the reason.
There's one thing I would like to add on here. So we do consider TBD though for internal frameworks. As we mentioned before, we're looking into doing internal frameworks precompiled to share among apps, as those frameworks are released when you generate the new version of the framework and publish it internally. We're probably going to use TBD on those repos, as we can follow a continuous delivery and continuous deployment approach there. So just wanted to clarify this point.
Absolutely, thank you, Mauro. And I totally forgot that is true. For libraries, we want just to make everything just publish out after every commit. But for the apps, after all of this week release process, it doesn't make sense for us. And I'm going to answer another one. On Wednesday at 5, the app will go to beta. How do you handle supporting issues with beta? Are they a high priority and monitor, or just acceptable to maybe have issues? Yes, we monitor the beta during the whole week. That idea of having the beta thing. And every crash that we see there, even if it's just one crash for one person, since we have really low adoption, we try to assess them as soon as possible. And the same for bugs, logical bugs that are not crashes, that are also detected in beta. We try to address them as soon as possible and try them as a high. I mean, of course we set what is going to be the impact of these crashes, and sometimes we just fix them immediately, and some other times we think that we can live with them and just solve it for the next release. And I hope this answers the questions. Mauro, can you keep the latest ones?
Yes, so I'll start actually with one that is only about iOS, which is actually about Metric Kit. So the question is, have you considered using the Metric Kit tools for iOS performance and power? So as far as I know, and you can correct me if I'm wrong, Marco, Metric Kit is iOS 13 only. So as with all the iOS 13 and iOS 12 frameworks, we usually tend to discourage them internally. So because we support iOS 11 as minimum version, we do have some iOS 13 only features, like you can check it in the app. We have dark mode, we have some haptic feedback in the app. All of that is iOS 13 only, but for more, I would say core solutions or core platform solutions, like maybe Combine, SwiftUI, or Metric, things that are iOS 13 only, we usually don't invest time on them because they actually, we need to work around still for the rest. I still think that probably Metric might give extra context and extra information for the iOS 13 users. And it's true also, is a big majority of our code base. So probably when later this year, when iOS 14 comes out and iOS 14 plus iOS 13 is more or less the norm, if more than 95% of our users, maybe it's something to actually look into, adding this to provide even more data to our security platform. I don't know if this answers the question. I hope it does. And maybe I'm wrong about the iOS 13 thing. That's to be honest, I checked it last autumn. But yeah. Then there's another 3 questions. I'll try to group them around feature flags, feature toggles, A/B testing and stuff. So I'll go in order and then try to answer all in one. So first one is, how do you test new features, functionalities? Do you make A/B tests or other methods? How do you make decisions on what to keep? The second one is actually about user targeting. So user targeting at country level, or let's say for customers whose order value in Storic is, for example, more than 100 euros. And then the last one around this is, could you please provide a brief explanation about how your custom feature flag system works from a technical point of view using a specific tool, or how did you manage it? So to try to solve more, answer all of them. So this internal tool basically was built by our platform team. We have our own configuration panel in our administration panel in internal. So we can set there a certain set of variables around countries, cities, user targeting, but we don't have things like, for example, historical data on those users. It's also true that it's something that as we grow, it evolves. So we might get that functionality at some point. Then linking this actually with the first question I read, actually, how do we test new features, right? So at Glovo, and I think that this goes very in line with what Guillermo just presented, we are very data driven. So we really need to make sure that we have a really good set of data analysis around what we ship and how we ship it. So every feature, so feature toggles, as I said in the presentation, is not only about engineering, it's also about product. So we use feature toggles or feature flags in this remote configuration that we have to A/B test, to phase rollout, to test only in this segment, to target based on these conditionings that we have. And then we use our in-particle and this multi-platform library that Guillermo has been presenting into feeding these into our systems. And then our data engineering team actually can see how these perform. And based on pure data, based on conversion rates on the funnel, based on orders, based on signups, based on all the usual KPIs that you can expect from a company as the one we work in, we take the decision of, is this new screen actually up to what we wanted? Yes, no, should we revisit it? And we bring this data back also to our UX UI team to also maybe look into the UX if we found some flaws and maybe something that we can enhance. So I would say that data is actually a core in this, and we use feature flags to actually target this segmented set of users. And yeah, I hope this actually answers the 3 questions. I tried to not send myself too much. Let me know if in the comment, or just you have at the beginning, Roldan shared our Twitter, even though Guillermo said he doesn't use it much, but Twitter or maybe any other means, just feel free to send us a message on Twitter or anything after this talk.
Yeah, maybe if anyone wants to raise your hands, we can give you a talk option if you want to do any follow-up or something like that. If you don't.
Yeah, I think there's a few questions though. There's a few more questions.
Yeah. So I can start answering some related to the multi-platform if you want to.
Yeah. Okay.
So let me answer this one from my colleague from Chile. So it is any limitation for using for Kotlin Multiplatform in order to use LX Java? And the answer is you can't. So any library that you know for Java, to get it work in Kotlin Multiplatform, first you have to migrate everything that is shareable into a common source set. You have to rebuild it. You have to migrate everything that is Kotlin only, not platform specific, to a common source set. And then you have to resolve all the platform specific stuff into, for instance, if you want to use LX Java into an LX Java converter or whatever. So LX Java is only for JVM and it cannot be used for Kotlin Multiplatform. But it doesn't mean that you cannot have a reactive stream framework in Kotlin Multiplatform. I don't know if that already exists or not, but you can totally do it. So I don't know if that answered the question, but I think it does. But anyway, so what's next for Kotlin Multiplatform exploration? And honestly, I don't know. I like to, but I need to wait a little bit that is more mature. I would like to start trying the serialization project, which is a multi-platform one, as a replacement for JSON or whatever serialization framework that we have, because it has a cool features that you can write everything in Kotlin and you can just use it at any platform. And you can switch in live the underneath protocol. You can use JSON, you can use XML, you can use protobuf. So they have all that stuff resolved right now, but it is still incubating. So it's not, you cannot use that in production. Besides that, I open to suggestions. So if anyone wants to tell me or guide me on what we should put focus on, I would like to hear about you. I think the last one regarding this is, are you going to open source this? The answer is, hopefully I can do that. It's my goal to do that. At least the publication plugins for NPN, Cocoa Pods, and also the multi-platform plugin. We have several more, but I'd like to open source them. I'm working with our BTD team to do that, but yet. It's not done yet, but we want to do that, yes. And I think that's all. Oh, there's another
There's one last one.
Scale up for, so if we're going to consider to scale up this for a larger scope, I think it will depend on the adoption of the teams, how they comfortable are they with this. But I already identified some other stuff that we can build like this to avoid repeating ourselves in all the platforms. For instance, our feature toggle service or metric service that right now we have for data integration, we have different SDKs per platform, and every change we want to do, we have to do it in another platform. So this could be also a project that can be done with multi-platform, but right now is what we have already. So now I think that's all. Yes.
Yeah. There is another question that I think is in general. Do you have architecture board or architecture guild of sort to decide a line on critical technical decision? Not a specific one, but we have committees that are composed of members of all the members of a certain platform. So we have the Android committee, the iOS committee, the backend committee, front-end committee, etc. And in this, we have an horizontal organization, and these committees are purely horizontal. There is no tech leads, there are no managers in these committees. These are all the developers, all have rights to talk there, and we try to have consensual decisions there. Also, we have RFCs, requests for comment documents. So for any important technical decision, any new big feature, any new big refactor, any impactful change that we have in our code base, we have to send this RFC. You need to pick some approvals of relevant engineers that maybe can provide some value or that are going to be impacted by your change. And this is sent to the whole engineering team. So more than 100 people or at least the ones that are going to care about this, they are free to open your document, read it, and add any comments as they want. So this is basically the two ways where we take architectural decisions here at Glovo. There are no more questions. I don't know if Mauro or Guillermo want to add something. There are no more questions here. Any attendee want to raise something, want to say, add some follow-up or any follow-up questions that is not fitting in our text? Just raise your hands in Zoom, and we can give you a voice access if you think that you can upload your question, or otherwise we are done.
Yeah, just a reminder of the form, the feedback form.
The form was the link. I didn't notice it was done inside the Glovo organization, so there is no access for outside. We'll send the link with the slides and with the video and everything, probably from Meetup or whatever in the next updates.
Okay, I think yeah, that's the problem.
We didn't notice that everything in Google Docs we have no access for external non-Glovo employees, so we are not having that. And I think that's all from our side. So since this is a meetup, it's time for pizza and beer.
Yeah, so thank you very much all for joining. This is the first time we do something remote like this in Glovo, which is special and different and weird. We cannot hang now for the beers and pizza. The recording of this call plus the slides will be shared soon. So yeah, thank you very much, and feel free to contact us through the means that we shared earlier today with any further questions or ideas. Thank you very much.
Have a nice day. Oh.
Ciao. See you all. Bye-bye.
Bye.
Yeah. Are you turning off or?
Yeah. Do you want to stay or shall we close?
I don't know. Everyone has almost left already. There's a few guests.
Cool. See you. Bye.
Okay, I'm leaving too. Maybe I can have a walk. Bye.
Good luck.